Welcome to one of the Week 4 videos in the Utah Conservatory's Music Theory for Composition course. Today we're going to be talking about the basic unit for measuring distance between pitches, which are whole and half steps. We will also be talking about how we use these to build major scales. When we're building scales with our letter name notes, we do so in alphabetical order, starting over at A if we go higher than G. Does this mean that all of our notes or pitches are going to be the same distance apart? While the answer seems like it should be yes, we actually have different distances between pitches. This helps to create kind of a contrast within the scale. For more information on this, see the video listed in the comments and under the optional videos section called Richter Scale Example, Why Different Scales. To see the differences, let's look at a couple of notes in the C major scale. Let's start with a C and a D. These two pitches are both one letter name note apart in our C major scale, and when we play them separate and then together, they sound like this. Now take a listen to a B and a C, which are also just one letter name apart. As you can hear, these have different sounds to them, even though they are just one letter name apart. The distance between a C and a D is a whole step, and the distance between a B and a C is a half step. If we were to look at our full C major scale, we would find two places where we have half steps between the pitches. These are between the E and F and between the B and the C. Now let's take a second to look at what would happen if we had all of the pitches equally spaced. How would this sound? This would actually sound kind of strange, sort of jarring, and very unfamiliar. Let's try it and see what happens. Here again is our C major scale so that we can hear the contrast in how these different scales sound. Now we have a scale with all whole steps, which we refer to as a C whole tone scale. When we listen to this whole tone scale, it has an almost dreamy and incomplete sound. Now let's see what would happen if we were to make all the distances a half step apart. We refer to this kind of a scale as a chromatic scale, and it has a very tense sound to it. While there are times where composers have used the tense sound of both a chromatic scale or the dreamy sound of a whole tone scale, most songs are built to have a varied pattern of whole steps and half steps. So if different patterns of whole and half steps create different sounds, how then would we go about determining the pattern of whole and half steps for a scale? This has to do with the overall mood that we're trying to achieve, because different qualities of scales will create different moods. These different qualities are determined by the pattern of whole and half steps that we use. For a happy sounding scale, we want to use a major scale pattern. To learn how we build a major scale, we first need to start with tetrachords. So the Greek root for the word tetra stands for 4, and tetrachords are a series of 4 sequential notes. Different tetrachords are built using different patterns of whole and half steps. To build a major scale, there are 3 different things to remember. First, we need to start with the major tetrachord. And to build this tetrachord, we start with our bottom pitch and then go up a whole step, and a half step. For visualization purposes, I'm going to represent these as different colored blocks. The second thing that we need to remember is that we need to go up a whole step from the highest note of our last tetrachord. The highest note of our last tetrachord was an F, so we will be going up a whole step from the F to a G. The third and final thing to remember is that we build another major tetrachord. We start with the last note we left off of, which was a G, and from here we once again go up a whole step, and a half step. This brings us to the last note we started on, which was a C, and that ends our major scale. When we're done, our whole major scale pattern looks like this. Whole, whole, half, whole, 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 half. In addition to the basic distances of whole and half steps, there are also other distances, most of which we'll talk about in a later video. One other important distance, though, to know is an octave. From the lower C we started with to the higher C we ended up with, we have a total of 8 notes, and this is what we refer to as an octave. Let's say now that we were to start our scale on a different note, such as G. So our first tetrachord looks fine with a whole, whole, half pattern, And we would also have the whole step from a C to a D. The problem, though, is in our last tetrachord. There's an issue here. Since the pattern in this second tetrachord is whole, half, whole, we have our half step in the wrong place to make this a major tetrachord. If we needed to indicate to a musician to change distance between certain notes, how could we do that? This is where we can use accidentals. Accidentals are used to change notes from their C major position. There are flats that lower a note by a half step, and there are sharps that raise a note by a half step. And a natural would return a note back to the original C major position. Now, as a general rule, accidentals apply both to the note they're in front of, but also the rest of that same pitch in the rest of the measure. Let's go ahead and let's take a look at an example to see this. The first F in our measure here would be an F natural, and the next F would be a sharp since we have an accidental that indicates that. The F after that would also be sharp since we haven't yet finished our measure, but the F at the start of the next measure would be an F natural again since it's the end of the previous measure. We have another F sharp because of the accidental, followed by another F sharp. Again, we haven't finished that measure yet. However, the last note, if we wanted to make that last note in our measure an F natural, we'd have to indicate this with another accidental, in this case, the natural sign. What we could do then is to take our scale from before and raise the seventh note by a half step, making that note an F sharp. That now gives us our major scale pattern of whole, whole, half, whole, 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 half. And because this major scale starts on a G, we refer to it as a G major scale. Now this brings us to the subject of key signatures. If we're going to be using a lot of F sharps because we're going to be using the scale of G major, we wouldn't want to have to write this out every time. And what if we were to use a scale that has several sharps or several flats in it? This is where key signatures come in, and to make it easier both to write down and also to read, we will write the accidentals at the beginning of the song, and at the beginning of every line is just a reminder to the players where our accidentals are. And if we have a large section that starts using another scale, we could also write this in to make it clear where we'd be changing scales. Now we refer to these different scale areas as keys, and the accidentals at the beginning of the lines as key signature. This allows us to not need to write out every accidental, and for the players not to need to read every accidental. In addition to major scales, there are other types of patterns that help create different moods. These are something that we'll talk about somewhat more in later videos, and they include minor scales, modes, and some other unique patterns. For now, if you learned something valuable from this free resource, please consider liking this video and subscribing to the channel so you can see more of these videos when they come out, and also liking the Music Theory for Composition Facebook page. Thanks, and I look forward to seeing you in our next video.